Welcome to our quantum deep dive. Today we're plunging into, well, a truly mind-bending topic, quantum sentiment analysis. It's all about using the, frankly, bizarre rules of quantum mechanics to understand human emotions hidden in text. And we're drawing our insights today straight from a really interesting essay by Jorgo Schneeppert. Quantum Sentiment Analyze Emotionserkennung mit Quanten KI. Okay, so let's unpack this a bit. Sentiment analysis. I mean, it's already huge, right? Companies use it for customer feedback, political campaigns track opinion, researchers watch trends. It's everywhere. But what are the limits? Where does current tech fall short?
Yeah, that's the critical point. Classical sentiment analysis, even the really advanced AI stuff, it faces some pretty big hurdles. Human language is just incredibly complex. Think about saying, that was not bad.
Right. Is that good? Neutral?
Exactly. A classical model often struggles there. It might just pick one, missing the subtlety. And sarcasm, that's another massive blind spot, often goes completely undetected. Plus, there's the sheer scale. The amount of text data flying around social media, news, reviews, it's astronomical. Processing all that classically demands huge computing power, and it can be slow.
So it sounds like our current tools are sort of hitting a wall, especially with the nuances of how we actually talk and write. And this is where quantum computing comes in, offering something radically different.
That's the idea. It offers a completely new toolkit, you might say.
So how do these strange quantum rules actually help us understand language better?
Well, the essay points to three core quantum principles that could really change the game here. First up is superposition.
Yeah.
Imagine a word like interesting. Could be good, could be bad, depends entirely on context, right?
Yeah, definitely.
Classically, an AI usually has to kind of decide early on or process probabilities sequentially. With superposition, a quantum bit or qubit can represent all those possibilities, positive, negative, neutral, simultaneously. It holds them all in a state of potential, a probability distribution, until the whole sentence is processed.
Ah, so it doesn't have to commit too early.
Precisely. It keeps the ambiguity alive longer, allowing for a much more nuanced interpretation. It can weigh the context more effectively before collapsing to the most likely meaning. Think about catching subtle sarcasm. Superposition could be key there.
That makes sense. It feels more flexible, more like how we process ambiguity. What's
Yeah.
the second principle?
The second one is Verschränkung, which translates to entanglement.
Ah, the spooky action at a distance thing.
Sort of, yeah. It's that weird quantum link where two particles remain connected, influencing each other instantly, no matter how far apart they are. Now, apply that to language. Entanglement could potentially model the deep, intricate connections between words in a sentence, or even across a whole text.
How's that different from current methods, like word2vec or BERT?
Well, those methods are powerful, no doubt. They create these vector representations based on how often words appear near each other. It's statistical. Entanglement suggests something maybe more fundamental, a way to capture how meanings inherently influence each other within the structure of the language, perhaps more efficiently and more deeply than just statistical co-occurrence. It's about mapping those simultaneous relationships.
Okay, so it's like seeing the whole web of meaning at once, not just the individual threads based on proximity. Interesting. And the third one?
The third is quantum parallelismus, or quantum parallelism, and this one's really about speed, a massive speed boost.
Right, because the quantum computers can do many calculations at once.
Exactly. A classical computer crunches numbers one after another sequentially. A quantum computer, leveraging superposition, explores many possibilities simultaneously. So imagine searching for specific sentiment patterns, say, signs of emerging unrest across millions of social media posts in real time.
That would take ages, classically.
It could. But a quantum algorithm like Grover's could potentially speed that search up exponentially. We're talking, theoretically, going from needing n steps to something like the square root of n steps. It's a huge leap.
Wow. Okay, that level of nuance, that kind of speed, it sounds incredible. But the big question, are we actually using this today? Is quantum sentiment analysis out there in the wild?
That's the reality check moment, yeah. The potential is enormous. You can easily imagine applications in finance predicting market shifts from news sentiment.
Or social media analysis, like you said, real-time trends, maybe even spotting disinformation campaigns faster.
Absolutely. Even medicine analyzing patient notes or feedback for subtle emotional cues to improve care. The possibilities are vast. But, and it's significant, but Current quantum computers are still very much in their early stages. Think early days of classical computing,
Meaning?
meaning they have a limited number of qubits, the basic processing units. They're prone to errors. Something called quantum noise interferes with the delicate quantum states. Maintaining coherence is really, really hard.
So not quite ready for prime-time deployment on a massive scale.
Not yet. So what we're seeing now, and what the research is focusing on, is developing hybrid approaches.
Combining classical and quantum.
Exactly. Using classical AI for the parts it does well, and then offloading specific, really hard computational tasks, the ones where quantum might offer an advantage to small quantum processors. It's about leveraging the best of both worlds as the technology matures.
So it's emerging, piece by piece.
Very much so. It's an active field, moving from pure theory towards practical, albeit maybe niche, applications first.
Okay, so for you listening, what's the main takeaway here? While full-blown quantum sentiment analysis isn't something you're interacting with daily just yet, the ideas Jirgo Schneppe discusses in his essay really point towards a future where AI might understand the nuances of human emotion and language with the kind of accuracy and speed that's, well, currently out of reach.
And that, of course, brings up important questions, too. As this capability grows, what are the ethical implications? Think about privacy, freedom of expression when sentiment can be analyzed so powerfully and instantly. It's definitely something to watch closely.
Absolutely, a field with huge potential and significant questions to navigate. If you want to dive deeper into this fascinating topic, you can definitely explore more of Jirgo Schneppe's work over at schnepphat.de. Thank you for joining us on this deep dive into the quantum realm of emotion. We'll catch you on the next one.